All right, guys, what's up? Today's day 86, the 100 days of LeetCode. We got problem 19. It's removed nth node from end of list. If you guys have been liking these videos, please like, subscribe. It would help me a lot. It'd be cool. So yeah, let's get to it. Given the head of a linked list, we want to remove the nth node from the end of the list and return its head. So we have this list here, n is equal to 2. This is the nth node from the end of list because it's the second last index. It's the second last node, excuse me. So we remove that, and now the list is just that. Here we have head equals 1, n equals 1. We just remove the head. Example 3, pretty similar. Now, something important that's said here in the constraints is it gives us the number of nodes in the list is size, SC. And 1 is less than or equal to n, less than or equal to size. So we're always going to have a valid n. We're not going to have to do any checks to ensure whether or not n is valid. So that's an important little tidbit from the constraints there. Okay, so what we're going to do is we're going to create a slow pointer and a fast pointer. Okay. And essentially what we're going to do is we're going to take the fast pointer and we're going to move it forward n+1 positions. And then we're going to move both of the pointers forward 1 position until they get to the end. And then at that point, the difference between the slow and the fast pointer will be n+1. So we'll just be able to skip a node with the slow pointer. And then we're just going to return our head. Okay? And actually not return our head. We're going to return sort of a placeholder value that we'll create. But that's basically our solution. We're going to first iterate our fast pointer forward n+1 positions, and then we're going to keep going for both of our pointers 1 position at a time, 1 position at a time until our fast pointer is outside of the list. And then we're just going to skip a spot with our slow pointer. So it's going to look like this. We first initialized our 2 pointers. Now, we're going to create, I'll just call it placeholder. And we're going to set it equal to slow. And the reason why we need that is because there might be a situation where our head gets changed, right? Or it gets removed from the list if the n is the correct number. So we're actually just going to create this placeholder instead of returning head at the end, because at the end we're just going to return placeholder that dot next. So even if this this head gets sort of removed, this is still going to have a dot next, which would be the node after the head. So we can just return placeholder dot next at the end, and that's what we're going to do. We're just going to return placeholder dot next down here at the end. Okay. So now what we need to do is we need to do basically our operations. So we're first going to move our fast pointer ahead. So fast equals fast.next, right? Okay, we're going to do that n+1. And then we're going to say, okay, that's perfect. Now we need to basically iterate them both forward, right? So we're going to say, well, fast not equal to none. Fast is equal to fast.next. Slow is equal to slow.next. And then we're done that loop, right? So this is going to keep going until fast is none. And then what we can do is we can just say slow.next equals slow.next.next. So we're essentially just skipping a node here, okay? And then we're going to return placeholder.next. And that's because we need to set fast.next up here to head as well. Okay, so there you go. That's one way to solve this problem. That was day 86 of the 100 days of LeetCode, and we'll see you tomorrow for day 87.